Welcome to today's presentation, Repackage, Don't Rewrite, Improving Portability and Agility of Legacy Applications with Habitat. Ricardo, why don't you kick us off and tell us what you're going to be covering here today?
Terrific. Thank you so much, April, and welcome everyone to today's webinar. We're really excited to talk to you today about how you can take advantage of today's modern cloud technologies without requiring you to rewrite your applications. We'll explore how Habitat allows you to package and build your applications in one way and deploy them anywhere. This is super valuable in today's world of cloud, where our customers want to have the flexibility to deploy their applications and workloads anywhere. We will go through the challenges faced by application teams today and show how Habitat can help. Let's get started. So to frame the current state, Chef ran a survey on the state of application delivery earlier this year. The survey encompassed 347 applications and operations professionals worldwide. Our research aimed to understand current and future IT environments and application architectures. The survey also focused on application lifecycle processes and timelines, as well as successful deployment metrics. We posted some of the questions in the survey in the webinar for you to provide your input. So as April mentioned, we'd like to make this webinar as interactive as possible, so we're posting a poll, and we'd like to understand from the audience, how do you measure success for your application deployments today? We'll give everyone about 30 seconds, and then we'll move on. Excellent. So we see we have some of the respondents, and 68% of you actually responded quality, while 27% responded with speed. What's interesting in our survey insights is that the first set of results from our survey revealed data points that everyone on the webinar clearly understand. Application deployment success is usually measured by how fast we can deploy. So we saw that 72% of those surveyed in our survey say that speed is the most important measure of success. Now, the other interesting parts of this first part of the survey is that you contrast that with the current state of how long deployments actually take. It takes 60% of respondents days, weeks, or even months to complete the build process for applications. 51% need 4 to 10 builds before an app can be deployed. While speed is the measure of success, we seem to have a challenge with being able to actually deliver on that outcome. So we saw in those initial survey results that speed is the primary measure of success for apps and the current challenges that app developers face. Now, when we start to look at modernizing those applications, we see that just over half of our respondents said that a quarter or more of those apps would eventually be deployed on a container platform. Yet almost 3/4 of the respondents said they'd lift, shift, then modernize their applications. It's an interesting set of data points that highlights an aggressive approach to containerization with a focus on lifting, shifting, and modernizing those applications. Again, highlighting that speed being the measure of success for applications, we actually have a lot of different deployment patterns or deployment targets that we're pushing through. So we've got another poll that we put out there. We want to gauge from our audience where or which clouds are you deploying to currently, and we'll give you again about another 20 seconds or so to go through that. Move the poll another 5 seconds as we see the answers coming in. Terrific. So not surprising, there is a massive, massive heterogeneity today in deployment targets within where we're deploying our applications. We're deploying everywhere, right? We're deploying AWS, Azure, Google Cloud, on-premise, or even some other technologies such as serverless. And this heterogeneity is really important to highlight because it actually adds a lot of complexity to how you deploy your applications, right? And your application being really important, you still need to be able to have those deployment choices in mind. So now coming full circle here with this, we're actually looking at this in terms of speed. And so organizations moving to the next platform while they're still carrying the legacy weight of those existing applications. It's difficult to manage because of that mix, and it's going to get harder. So now is really the time to start thinking about a comprehensive application strategy, and we're going to show you how in the next couple of slides. So while everyone might think about legacy as old or outdated, in reality, legacy is shorthand for critical business applications with longevity. But this longevity actually creates manageability problems. Take the examples we've shown here. While all the business value is in the application, those applications are tightly coupled to the middleware and operating system that they run on. So even though the business value is in the application, you carry all of the underlying burden of the middleware stack and operating system stack to support it. Heterogeneity is a reality and will only continue to increase as new technologies continue to surface. Even today, with the vast array of deployment targets available, heterogeneity is a huge blocker for speed. How do we extract the application's business value from the underlying infrastructure to improve its manageability? A compelling stat from our survey showed that 89% of respondents, given their ideal state, told us that they desire a cross-environment application packaging solution. Enter Habitat, a cross-environment solution that lets you package apps once, both legacy and cloud native, and deploy them anywhere, from traditional data centers to containerized microservices. We call this application automation, which is essentially all the things that it takes to make this goal true. And obviously, anything works great in greenfield, right? Of course. But we're here to talk about the real challenge most organizations face today, which is how do they move their business-critical legacy applications to modern platforms? Habitat works by splitting the platform independent part of the application, also known as the parts that actually drive business value, from the platform-dependent parts of the application, which are usually the components that we are trying to mitigate against risk, such as the operating systems. The application build starts with a clean room development environment, where the application and its dependencies are tested. We are defining all the things we need to be able to run our application without assuming anything about the underlying infrastructure it runs on. Once that application builds successfully, Habitat exports the application to what is called a Habitat artifact, or heart file. By splitting the application into a platform-independent artifact, I can now run my application on any deployment target I choose, from bare metal to VMs to containers, and even services such as EKS or AKS. From there, the application is managed in a supervisor, where the application runs. In the supervisor, you can define topologies for your applications, such as standalone or leader follower, for more complex applications, say, that include databases. And the supervisor also allows you to inject tunables into your application, allowing you to defer decisions about how your application behaves until runtime, which is a massive benefit when talking about consistency and portability of our applications. So why is this different? Traditional approaches are fundamentally flawed because applications are typically built from the operating system upward. Application development is done with the assumption that the required libraries are just present for it to run, and this assumptive approach leads to challenges as applications move through the progression from development to QA and ultimately to production. The larger impact here is that you also need to carry the entire operating system to support the application, which leads to having to keep end-of-life operating systems around for what seems to be forever. Habitat changes this approach. By starting at the application and building downward, we declare only the components that we need for our application to run, and nothing more. This provides consistency, so when an application builds successfully in my clean room development environment, I can ensure that the application can run anywhere. This also adds safety, as the surface area for application components is reduced to only what is required for the application to run. Added to this, the embedded supervisor as our standard management interface allows us to inject the runtime variables, such as port numbers for my applications, making our applications extremely portable by allowing us to defer decisions about tunables in our applications to runtime. The supervisor also gives us the ability to take advantage of cloud-native primitives such as RESTful API endpoints for health checks, even if our application does not natively support them. And so outside of talking about what Habitat is and how it works, it'd be great to show an actual customer success story around Habitat. So this customer was a large auto manufacturer moving their commercial off-the-shelf application to their next generation data center. It's a legacy application, Windows running in Vol and Delphi on Windows 2003 in Portuguese. A lot of value in the application, very painful, and I'd even argue probably difficult to impossible to actually rewrite. So the solution with Habitat is that we package the application and its dependencies into Habitat, what we talked about earlier, that heart file, which includes all of the components that is required for that application to run. We're able to deploy that application to the customer's next generation data center and beyond. So now everything is self-contained within that Habitat artifact, and now I can actually get better manageability. I can manage the application through its life cycle, updates, patches, et cetera. And essentially I can maintain the value of that app without having to rewrite it and have the customer take advantage of those modern technology and those modern platforms. So the customer evidence really speaks for itself. Habitat provides its application teams with the ability to have a reproducible and consistent method to build and deploy their applications. The same model can be applied to every service or application that you are running. By separating package and build from deployment, you increase your speed without sacrificing and even improving on the quality of those releases. Now, to hear more about Habitat and to get into the particulars, here's Jason Layn. Jason, take it away.
All right, let me unmute myself. Thanks, Ricardo. Yeah, so we talked about, let me move my slide. There we go. So what Ricardo was talking about, we talked about the benefits and the problems organizations face when they maintaining legacy applications. And these applications are critical to business, but they're often tightly coupled into their infrastructure and the operating systems that they're originally built against. This makes our legacy applications difficult to migrate to modern environments requiring one of two strategies. Lift and shift, where the full infrastructure stack is migrated to a new platform. This is typically the quickest initiative to get going, but doesn't really change how we manage our applications or reduce the technical debt associated with them. Alternatively, we can rewrite and replace. This has the benefit of allowing us to fully embrace emerging technologies like containers, but often is prohibitively expensive and difficult to budget for. And also, you're now starting with a broken application, an application that does not work. One of the benefits and values of legacy applications is, hey, I've got something working here, and that's great. And we kind of want to keep that. There's definitely some value to that. So today we'll see a third option, lift, shift, and modernize. To demonstrate this pattern, we'll be working with a simple application taken from Microsoft's Codeplex archive, SQL Web Admin. SQL Web Admin provides a web UI for interacting with Microsoft SQL Server 2005 and is tightly coupled with ASP.NET 2.0 framework and Windows Server 2003. In fact, the most recent issues tracked on the Codeplex archive is the user expressing frustration that they cannot get the app to run in Windows Server 2008 R2. To say nothing more about operating systems like Windows Server 2000 or 2016. Of course, that's exactly what we're going to do today in our demo. Let me start sharing my screen. By using Habitat to bundle SQL Web Admin with all the runtime dependencies, we're able to deploy it to any Windows server without needing to depend on the operating system to provide any of those dependencies. We'll also see how packaging our application with Habitat We can manage even our own old legacy applications the same way that we would do it if this was a brand new developed software without having to rewrite the old application itself. So we'll kind of see some of the ways that we can do this. And let me hit the second button to share my screen. So I've got a Windows 2016 server here. And we'll start by looking on how Habitat builds artifacts. Each Habitat project contains a plan which defines application metadata, build, runtime dependencies, and the steps required to install and run our application, written in the platform native shell, PowerShell in this case. If this was a Linux system or Linux application, we'd be writing these in Bash. So these plans can be built within the Habitat Studio, which is a clean room development environment that can be launched on any workstation to ensure a consistent build process on any developer or operator's machine. So if you're coming from the chef world, think of the clean room as your test kitchen. It's a place where you can kind of go and build and try out things, and if it doesn't work, you can blow it away real quickly. Once they've been built, Habitat artifacts can launch via the hab command line utility, which will deploy our applications alongside a supervisor service we can use to inspect its running state, apply configurations and updates later, and check out a log file and supervisor log to make sure that everything's running okay. So now let's get to the demo itself. All right, so let's start to look at this in action. So the first thing we'll do is we'll enter our studio. All right. So for this demo, we've already built our artifacts to speed things up, and I have them in here in a results file, Jason, not result. So we can see here we have our heart file. And the heart file is our artifact that has everything we need to run SQL Web Admin. To launch our application, we need to load it into the Habitat supervisor. And we see our screen there, and we're going to use our get supervisor log PowerShell command, and now we can start to see that this is running. So once our application is loaded, Habitat will start running through the installation process, which we can view in the supervisor log. As mentioned, the installation commands are written in PowerShell, and we can see Habitat is applying PowerShell DSE scripts to complete the configuration before launching our application. So now we see in here SQL Web Admin is running, and once in our browser. Hey, look at that. It works. Success. Our build was successful, and we now have a legacy application running on Windows Server 2016. However, since SQL Web Admin is an application designed for administrating databases, we'll need to give it a database to communicate with before we can do anything really meaningful with it. It's like, yeah, okay, so we've kind of got the web front end built, but let's go and actually put SQL Server 2005 in here. And how we do that is using our supervisor ring. So our web front end is just part of a multi-service application. Being able to build and run it on a modern operating system is a good first step. But to manage real world workloads, we need to make sure our services have facilities to easily communicate with one another. In Habitat, services are deployed into a supervisor ring, where each running service can automatically detect their peers and dynamically update configuration parameters as needed. For our application, this means we need to add a database server to our ring so that SQL Web Admin has a database to configure. That makes sense. Habitat artifacts are stored in a repository called a depot. And thankfully for us, in the public Habitat depot called builder.habitat.sh, we already have a SQL Server 2005 artifact in our core plans. Habitat plans for commonly use the builder habitat.sh site as a supermarket. When launched into a supervisor ring, Habitat applications can set service bindings at launch to specify which services they need to communicate with without needing to hard code IP addresses or ports. The appropriate values are queried and interpolated from running peers. All right, so let's go back into our demo here and close this real quick. Keep our supervisor log open because we're going to use that later and make sure that we're running correctly. So one thing I'm going to do is I'm going to actually go and unload my SQL Web Admin right now. All right, so we see that that's stopped. And what I'm going to do now is I'm going to do a load. I'm going to load up our database. So this is a core plan. So I have this locally cached, but what this does is actually goes out to our builder website and would download this into our supervisor that we're running here in our clean room. And we'll wait, just like as we did with our SQL Web Admin artifact. Habitat will go through any installation steps first before confirming that our database is running and ready to accept connections. We're validating this by looking at the supervisor log, but services are also able to query their peers running state to ensure that they know when it's safe to initiate a connection. All right, so we're up and running here. So now that our database is running, we can now again load our SQL Web Admin database or our SQL Web Admin application, but this time we'll specify a binding to our database service. So let's go ahead and do that. So I'm going to go bind. Oh, let me go and follow this. Make sure I do everything in all the right steps. Go back to our log here. This time when SQL Web Admin starts up, we can see that the supervisor log will confirm that the bindings that we've set satisfy its requirements. In other words, it checks to see whether the configuration parameters it needs, IP address, port, etc., are available to the running service group so that it can configure itself accordingly. All right, I spelled it correctly. Awesome. So now when I go back into SQL Web Admin and I go to databases, I now have databases here. Hey, that's great. So now we have both pieces of this, right? So now we have the SQL Web Admin and we have the SQL Server databases all running on this one machine. Now, again, based off the supervisor ring, we could have this on another host, a node, or whatever, to be able to go into here, because again, that supervisor ring has that gossip protocol that goes and checks all of those things out. So again, when we load this, we now can confirm that it's able to talk to the database. And that's great. I mean, now we can inspect and modify them as we're needed, just as if we're running on Windows 2003. Going back to the slides. Even though we haven't had to refactor our application code, we can already see some of the benefits of modernizing with Habitat. Instead of hard coding configuration values and thereby locking ourselves into rigid deployment architecture, we can now set dynamic binding so the services can auto-discover their peers. This is just the beginning of how we can apply modern application management principles to our legacy applications. Some changes we might want to make don't actually require altering our applications itself, but simply updating configuration parameters and reloading associated services. These can be expressed as variables in Habitat, which allow for operations to be modified in tunable parameters, just basically via simple CLI commands. The Hab CLI can make an API request to the supervisor ring and apply updates to any single service or an entire service group as needed. When config changes are applied, Habitat applications will run whatever hooks are required to reload their configurations in response to that change. So let's actually go and do this. We're going to go and make a change. Get this out of the way. So what we're going to do is we're going to change a port. So changing a running port of a service, by default, our SQL Web Admin application is running on 8099. But we can modify this, and we want to run it on port 8080. So let's go ahead and do that. Checking my spelling. Yeah, I think that's right. So now we see here that basically what I did was I'm telling Habitat to update the port to 8080 and applying that configuration of the SQL Web Admin default service group. And our supervisor log output, we can see that we're stopping the application and we're making the changes that we've requested from the CLI. And now that we see it up, and now if I go back into here, if I do a refresh, I get a timeout, right? But if I go to 8080, all right, it's back up. So very simply and very easily, we can still see it's running, but our configuration update has been applied. And that's pretty cool. So what we've seen so far is just kind of the tip of the iceberg as far as the workflows we can implement with Habitat. Habitat applications can be configured for automated updates, clustering strategies, rolling restarts, rolling deployments, and more. Additionally, Habitat can not only help you run your legacy applications on modern operating systems, so like we're just kind of running this on a, I'm running this in Azure. I've got a VM with Microsoft 2016 running here. But we can also start to target emerging deployment technologies like containers and whatever the next thing is going to be after containers. I mean, who knows? In 4 or 5 years, we may be running all of our stuff on something different. So Habitat features the ability to natively export your artifacts to a variety of container formats like Docker. Once exported, these containers can be managed with their platform native tools like Docker Compose. That said, even when launching as a container, Habitat applications have all the same tools for binding and lifecycle management that we've seen so far. So next step in our demo, we're going to actually show this off. I'm going to be a good administrator here, and I'm going to actually shut everything down. So pretty simple unload and load services on here. And as I'm doing this, just to give a plug, there are tutorials out there on habitat.sh, and they're also out on our Chef Rally or learn.chef.io training site. And I can do a status to make sure we're clean. We are. My studio, or exit my studio. And what I can do now and see what we've kind of done here. So once again, we've done our Docker exports ahead of time so we can see we both have if we do a Docker image list, you can see we've got our SQL Web Admin here. We've got our SQL Server 2005. And now if I do a Docker compose, so as these things fire off, you'll see in the terminal that we have the same steps Habitat took to launch our application locally. So we're seeing the same types of things that we saw in the Hab supervisor log. And again, the nice thing is too, is we also see that after the SQL Web Admin service loads, it waits for SQL Server to finish before applying the configuration before it connects. There it goes right there, waiting for SQL Server to start. Now SQL Server is running. Now it's going to finish. There we go. Now SQL Web Admin is running. All I have over here is a Docker inspect command to grab the IP address that it's running on. Going back to our web, we can now type in the IP address. And we're back into 8099. And there you go. We have the application. I can actually go and see that we've got the databases on here as well. So just like before. So now, again, the value of this is we have the same application, the same pieces that were running on our 2016 box here, now running in Docker. So that's really cool. And that's the value of this. It's with Habitat, whether you're running it on-prem or in cloud VMs or in Kubernetes, you can have one way to build, deploy, and manage every application in any environment. So yeah, that's kind of the demo. I see we've got a couple questions in here. And so right now is kind of the perfect time. If you have questions, feel free to put them in. So Todd asks a pretty good question. He asks, if the dependent libraries are packaged with the app, do you run the risk of several copies of the same library version running in memory on the same host? That's a good question, but that's the value of the HAB supervisor. The HAB supervisor is kind of the management piece between the host and the applications that you're running. So the dependency libraries and everything that's running is controlled by that supervisor, and that supervisor controls that risk of being able to run those the different copies and managing those nodes in a very, very simple and very easy way of being able to manage all of that information. So if you would see anything that would kind of crash, or if there was any kind of confliction or something like that, you'd be able to go and see it in the supervisor logs and be able to kind of figure that kind of stuff out. Another question from Justin. We get this a lot. My organization is currently looking at solutions akin to Habitat, like Pivotal Cloud Foundry. Are Habitat packages compatible with PCF? Yes, they are. The value of Habitat, in my mind, as there are a lot of folks that are like, hey, I've got Docker out there. Hey, I've got PCF. I've got all of these different things. The value of Habitat is I don't tie myself to one paradigm for container management. And I also have that one way of doing that build and deploy is kind of the value that you get if you've already kind of gone down the road of doing containers. And that's the thing that I see a lot when I go and meet with my customers is it's like, yeah, they've got Docker, they've got PCF, they've got Kubernetes, but it's kind of stuck in their lab. It's not really getting to a place where they're able to use it in production, or if they do, they're using it at a very basic level. What Habitat gives you is a very good way to be able to go and build your applications and put a pipeline around it. One of the things that we don't really talk about and show in this demo is kind of the pipeline functionality that we have along with Builder to be able to go and, again, have your application automation. So yeah, there are advantages from a standpoint of using this with PCF over, say, hey, this is going to replace it or something like that. I think Habitat is a good technology to allow you to fully realize your investment that you've made in things like PCF and Docker and Kubernetes and things like that. So that's kind of how I see those things, Justin. But a good question, very good question. Any other questions? Anything, Ricardo, that you'd like to add before we wrap up here? I'll wait a couple more minutes. Okay, I think we're done. If anybody has any questions, anything, feel free to hit us up. If there's anything that you have questions beforehand, just reach out to us at Chef. Again, go out to habitat.sh is where you can kind of learn to do things and look at all of this information. Oh, good. We do have another question. So we have a question from Bruce. Bruce asks, do you have samples where multiple large databases are managed, enterprise applications using large databases? Yes, we do. We have a lot of customers that are using or starting to use Habitat to manage some of the pieces from a standpoint of the application side of this and kind of maybe the front end of databases. Because again, at the end of the day, you have to make those decisions of, okay, do I really want to go and how static do I want to keep my database loads? Like, right, I'm not really going and putting all of my databases in stateless configuration containers and things of that nature. However, the nice thing about what we've done with Habitat is be able to use that to manage the front ends of those databases and the binaries and things that go along with those databases, as opposed to maybe the tables and the indexes and things of that nature. We can certainly have follow-up question, one-on-one things to kind of go to your specific needs with that, Bruce. But yeah, if you go out to the builder site at bldr.habitat.sh, you can see the different examples of things that people have gone out there and written as core plans to do things around databases. One of the things that we've done is we've done a lot of work around SAP, those types of applications with in-memory databases and those types of things. Again, it kind of depends on what you want to do, what you want to containerize, what you want to put a wrapping around to do. SQL Server 2005 is just kind of an example that we use for this, but yeah, we can do this for multiple large databases depending on what you want to manage and how you want to manage that.
Yeah, that's exactly it, right? And so you're picking your deployment target based on either your choice of what you need or what you might be constrained on. We know some vendors actually don't support things like container targets. And so, your freedom to be able to do that type of deployment where you have, again, multi-tier types of applications, you'll be able to make decisions about where, say, your databases run and resources for those, where your applications might need to run, all taking advantage of all of the things that Habitat gives you in terms of both the manageability of the packaging, the one way to package, and also the flexibility to deploy to where you need to deploy, and making deployment really a business decision.
Any other questions? Wait here, I don't see any other ones.
I can take it from here. I think we can wrap up. And any other additional questions, if you reach out, we will send follow-up reminders to you directly. And then as a reminder, a copy of today's presentation and resources are located in the resource list widget at the bottom of your screen. We encourage you to download the slide deck and bookmark any links you might have found useful. We, of course, hope you found value in all of the information that Ricardo and Jason presented today. If you like what you saw, we encourage you to share the presentation with your teammates and professional networks. The on-demand version should be available by tomorrow, and we'll email you as soon as it's ready. You'll be able to access it using the same audience link you're using now. Thanks again so much, Ricardo and Jason, and thanks all of you attendees for joining us, and have a great day.
Thank you.